but I went up to my room about 7:30 last night, and I sat on the bed with a book to read. I thought I'll read for a bit, and within 10 minutes I fell asleep and woke up at 7 a.m. this morning. So I'm like, okay, that's good.
There's something that I miss sometimes because I'm so busy. I use for a long time. I cannot go to sleep unless I read.
Yeah.
And at one point, yeah, but reach a point where I'm so tired. By the time I drop in bed, I look at my phone and I'm doing sometimes. You know what? I wake up because my phone fell down.
Right. Yeah.
Something like that.
Yeah.
And yeah, so yeah, it's actually too busy. I think.
Yeah. I actually find going back the other way is jet lag worse. Actually, going back the other way than this way. So you get it coming here, and then when you go home, you get it. So it's kind of like 2 weeks until you get back to normal again.
Yeah.
But all right. Well,
Oh, yeah.
Start.
Mm.
Password is there.
Do you want to leave 5 minutes more?
Hmm?
Do you want to leave 5 minutes more? Just to make sure.
Yeah, we can wait one more minute. You can start. Okay. Hi everyone. Welcome to the LISP working group. Okay, we will have 1 hour to spend together. Okay, Luigi here, Padma on my left. We are the chairs here. Alberto is not going to make it, our secretary, but he will help us out for the minutes. Okay. The usual note well, you are supposed to read this already when you register it. So basically what it says is that everything we discuss here is a contribution to the IETF, and if you have any IPR related to what we do here, please share with us, okay? And also another part of the note well is that we are here for technical discussions, nothing else, so we treat each other with respect, okay? For the persons that are remote, well, you logged in, and if you are listening to me, okay. For the people in the room, please scan the QR code so that everybody is signed in, because this is now the blue sheets, okay. The usual pointers for everybody that wants to see the materials. Yeah, we have a few changes since the last IETF. So we did a review of the RFC 8378 bis document, which is the signal-free LISP multicast. Okay, we sent a review to the authors, so we wait for a revision. I mean, this is a document that was experimental and now is going to be on standard track. So there are no real technical issues in the review. It's just a matter of editing and clarity of the text, nothing more. We need to request the publication of LISP geo coordinates. Will arrive at some point with the usual process. For the console plane ACDSA authentication authorization, we are waiting for the SecDir review, okay, because obviously it's related to security, so we need that review. 6831 bis, this is another multicast, LISP multicast document for which we did a review. Again, we sent the review to the authors, and they will at some point submit a new revision. As for the signal-free, honestly, it is moving from experimental to standard track. No real technical issues. It's about editing and clarity. Okay. There is a third multicast document in the group, which is the LISP group mapping. We didn't have time to make a review of this one. We will do it soon, hopefully. Okay. So that we can move this one forward as well. There is the LISP map server reliable transport. Blame on me. Actually, I have to review the IANA section. It was an action point of me that slipped out of my mind, and I will do it right after this IETF, and hopefully we can move it forward before 123 in Madrid. Okay. We have another draft that has moved forward, the LISP traffic engineering, the LISP-T. Publication has been requested, so the usual procedure, this will go through AD review, etc., until reaching the RFC queue. And LISP Miami model, this was on the agenda last time. The outcome was that there was a revision needed to solve some small concerns that were still there about from the young doctors. Nothing big, but yes, we need the new revision. Once we have it, this document is really close. It's ready for working group last call, I think. I mean, it's just a few changes that need to be done, and we are good to go. Okay. So these are the main updates on the status of our document. Another news is that we have a new RFC. It's the LISP distinguished name encoding. He was stuck in security review. There were a few concerns from the security ID that needed to be solved. They have been solved and has been published. So good. And this is the agenda for today. So we will have, first of all, Prasad that will share with us experiences with LISP multicast deployments. Okay. That there is LISP DDT BIS. So this is moving RFC 8111 from to standard track. So we need a new document. And actually, Damian Sose was supposed to present it, but he, with the switch of time slot, is not able to do it. So as a co-editor, I will do it. Same thing for LISP NAT traversal. This is one important document that we are chartered to publish it. He was expired for a while. And but this document, the first revision, I think it dates from 10 years ago. Just didn't have time to move it forward. But we took it and we worked on it, and I'm going to present you what we did. Has been approved by the former authors, because me and Damian, we were not authors, and now we are editing this resurrected version. And if you saw on the mailing list, Alvaro Retana volunteered to take care of the 8060 BIS, so moving LCAF from experimental to standard track. And he has a conflict, so he's not able to be here today to show you the plan, but we will try to replace him. He prepared the slides, so me and Padma, we will go over them to share with you the plan to update this document. Okay. And this is all for the agenda bashing. So unless anybody has something to add, I will hand over to Prasad for the multicast deployments document. Okay, Prasad. Also. Oh. Need to stop this maybe. And Prasad, can you hear us?
Yes, I can hear you.
Yeah. You want to share the slides directly, or I run for you?
Can you do it for me, please? I'll just use
Sorry?
them. Can you just share it for me, please?
Yes. Here we go.
Okay, thank you. Thank you. Sorry about the glitch. I had to reboot my PC. So, yeah, thanks everyone. So this is basically the as part of the 6831 BIS, I think there were comments to add sections for deployment use cases, and we thought that we'll probably have a separate document documenting the use cases. This is an informational draft, not a standards track one, but primarily intended to support the advancement of 6831 BIS. So I kind of had some offline review with Dino as well, and I think maybe we'll just go through it quickly here. So next slide, please. So yeah, in terms of scope of what the document covers, I mean, this particular deployment document, I think we cover, of course, basically 6831 BIS, whatever is specified there. That is LISP multicast, where you have LISP multicast, supporting both the L2 broadcast unknown unicast and multicast, that is the L2 BUM, and then the layer 3 routed services where you have the clients using SSM, ASM, or BIDR, all three types of multicast with the LISP underlay. Now, in terms of the underlay, we have both support for the native multicast underlay and then the head end or ingress replication, whatever we call, and then the different address families bring in their own kind of permutation combinations, right? So essentially you have four combinations that are permutations that you can get with V4, V6, and then the native underlay and native multicast underlay, and then the ingress replication, all these combinations. So we kind of cover them. And of course, overlays also, we have the V4 and V6 clients, so we cover all of that. The deployments, at least the use cases for the deployments that we have seen, range from temporary events like trade shows, just where a large number of people gather and leave quickly, or more an established setup like a hospital or an enterprise where users are a little more kind of stable. So different kinds of use cases are being supported. The reason why I bring up the use cases particularly here are some unique scenarios. For example, short-lived flows. One of the interesting use cases that we had was the public announcement systems at the airport, where the audio announcements were like low bandwidth, short-lived flows. They bring in some special considerations which we have tried to document. Those kinds of things. And other requirements. For example, how do you do some kind of segmentation? Those kinds of kind of use cases also add value by their business use case. But again, nothing particular in terms of mentioning these use cases in a reason, because there is nothing that we have to do to kind of have separate networks, but these networks bring their own perspectives. That's all I can say. Next slide, please. Next slide, please. Yeah. So sorry. So what is not in scope is essentially, definitely we don't want to cover L3 unicast rotate flows in the LISP, because that is not what is addressed by 6831. And of course, one particular point that I would like to highlight here is we've not considered the use cases for migrating from one underlay to another, because that is an important important requirement from customers, where they have especially deployed a LISP network with a particular type of underlay, most likely the V4, and then they want to upgrade to the V6 underlay for different reasons, right? That is not covered in this document. If people are interested, then that's something that is a separate work that has to be done. And of course, we do not consider underlays such as BAER. We are only considering IP-based underlays in this document. Of course, MPLS goes without saying that we are not covering it. And one last thing, last but not the least, I think we have not covered the multicast route leaking here. Although there are very important and interesting use cases for multicast route leaking on how that could be done, especially when you have things like CCTV cameras, where CCTV cameras, for example, being a very large user of multicast. There is a reason why the CCTV cameras will have to be placed in different VRFs or different forwarding domains, L3 forwarding domains. But then you want the RP, the multicast rendezvous point, to be in a shared VRF kind of domain, and that is predominantly one of the major use cases for extranet multicast, but that is not something that we will cover in this document. Next slide, please. Yeah, so 6831, probably this is not a new concept to this group. This is just using the PIM over PIM, which is the classic, multicast method. Going in the MVPN world, or the predating to the MVPN 68, 13, 14. The Rosen draft, what is called the Rosen draft. It's a very well understood mechanism, and I think that was one of the main reasons why that was applied to the LISP multicast as well. Primarily to provide a jump start to deploy multicast services. Now, why am I mentioning this? Because there is something called a signal free that has followed up after the signal, 6831. That is actually the native LISP way of doing it. So, as a LISP purist, someone would rather prefer the signal free method, but the PIM over PIM also has some advantages, and primarily the advantages being, what are listed on the slide, where essentially, it kind of solves the purpose, just in time kind of a solution where it meets the requirements. It may not be the purest method of doing it, but it kind of does the job. And at the same time, there are a couple of powerful constructs that we were able to leverage. One of them being using only SSM in the underlay, and the reason why that could be pulled off is essentially the fact that once you know that you have a star G join that you need to forward to the RP, or an SG join that you need to forward to your upstream multicast neighbor, you essentially go to the LISP control plane and quickly figure out where is the LISP site that is hosting the RP or the source in this particular case, and therefore you can convert the ASM into an SSM, and that is a very powerful, it's a very simple concept, but very powerful optimization, because it takes away a lot of complexity in the underlay. Because once you go to SSM, then you do not have all the complexities that are associated with the RP, star G state, and essentially that becomes a lot more simpler solution to deploy, assuming there is a native multicast underlay. Right now, when there is a mix, also you always know that the upstream neighbor is going to be determined based upon the simple LISP control plane lookup, and that kind of gives you a very simplistic way of doing multicast in the underlay. The one disadvantage definitely that has been there with PIM is that PIM neighborships are costly. In that sense, what I mean is really they are chatty. PIM is a chatty protocol, and having an O of n squared PIM neighborship between the different LISP sites essentially explodes the amount of control plane traffic that you're going to really have with especially PIM hellos running quite often. And that is one problem that we kind of worked around by essentially having the PIM put into a passive neighborship state where the hellos are not really exchanged. I think in the previous PIM working group meeting, Stig had a comment specifically saying that there is a PIM light RFC, and I think we can also update the draft to essentially, and even 6831 BIS, even maybe Stig can comment on it later, that we can essentially use or suggest to use that PIM light mechanism rather than going by the full-fledged PIM. And that will really reduce the overhead of essentially having PIM in the overlay. So, but with all the considerations, I think this has turned out to be a very powerful mechanism to deploy multicast services, essentially by reusing the existing traditional PIM code bases that many vendors would have, are even the operators are familiar with. So from the operational use point and the development use point, I think we have quite a good advantage there. Next slide, please. Yeah, so this is just a representative network that I've kind of used, but I think this is one area where we kind of need. I was essentially looking for 2 or 3 feedback points, and this will probably lead up to the first one. In that essentially today in the Lisp terminology, you have the Lisp sites. Essentially, every XTR is a Lisp site, and they're connected with some underlay network. But typically in the deployment scenario, what we really see is that these Lisp sites are kind of grouped into I don't know what the word to use right now. I will use the word domain, but I think that's the point I'm looking for. Feedback. On how to kind of define a collection of Lisp sites that form in an administrative domain or whatever you want to call it, and essentially interconnect many of these. In this diagram, I've kind of used the word campus. So it could even be a floor where essentially all the Lisp sites in that floor, are essentially forming a particular group of Lisp sites. I use the word campus, but we can still use the word domain here, I believe. But really, what do we call them? This is not needed for the specification. The specification is already done. We don't really have to need this term for the specification, but maybe some thought for some of the members to kind of chime in to see if there is a way that we can collectively describe a set of sites which form an administrative domain. The only what do you call the demarcation between them being essentially a handoff point where essentially you terminate the Lisp in this case and send it over the normal internet or public network, whatever it is, and then at another Lisp site you have another Lisp domain. You kind of re-encapsulate it into a Lisp. So I think there is some term that we probably have to use here. That's one of the requests I had for the working group. Next slide, please. And we don't really have to do it over the actual internet always. You could have a site of sites, right, where there are the re-encapsulating routers, the RTRs that will kind of convert from one Lisp domain to another, and then convert it back to a different Lisp domain on the other side. So you could think of essentially a hierarchical or a clustered site arrangement where a group of sites essentially lead to an RTR, and then RTR kind of does some re-encap, termination of the outer encap, and then re-encap again. It will do another Lisp encapsulation for the site of sites, and then hand it off to a destination site. Something like that. So this is a very common deployment model that we have seen just for administrative purposes. So that's most of what I had. I think last slide is there. There's one more slide. So yeah, just the request, how do we call them? Domain is one word. I think I suggested it to Dino, but he said that probably add it to the terminology section, and then we'll have to have a formal definition for it. So maybe that's something that feedback is welcome on what to do. Yeah, so that's the first item that I had. And the second item that I had is, which working group should this draft really belong to? Should it belong to Lisp, or should it belong to PIM, or should it belong to M1D even? That's just some thought for us to kind of brainstorm as well. So those are the two aspects that I had. Mostly that's it from my side.
Thank you very much. Any question or comment? Anybody in the queue? No. I have just a comment where the draft belongs. Are you presenting also in the PIM and the MBON working groups or not? This document.
Yeah, so it was presented in PIM. It was listed on the charter for M1D, but I believe the M1D was cancelled because of the lack of agenda of other drafts. So it is definitely already been presented in PIM.
Okay, but my personal opinion, this is experience about Lisp technology deployment. So I suppose it belongs here, but we can always discuss further. But okay, as a personal opinion.
Okay. Sure. Perfect. Actually, that's right. I put it in Lisp primarily because I thought that most of the content applies to Lisp more than anything else. That's I thought too.
Stig?
Yeah, hi, this is Stig. Yeah, I wasn't ready with the Meet Echo, but yeah, so this was presented in PIM, and I'm co-chair of PIM. I think it belongs in this working group. This is where you know, it's more about Lisp than PIM in a way, and it's
Yes.
also, you know, foundation for 6831. So yeah, that's my short answer. Otherwise, as I mentioned in PIM, there is a PIM RFC on how to do PIM without PIM hellos. That I think it's worth looking at and see how it's done in Lisp compared with that that PIM RFC. But that's just a minor detail.
Okay, thank you. As an additional comment, I mean, even if the document is adopted here, doesn't mean that, for example, the working group last call has to be. We can do also a call on the PIM mailing list to see if there is feedback, to see the document is ready, which is a plus.
Yeah, that would be good. Yeah, I would say from PIM perspective, one thing is, you know, we might potentially have some input on this, but it's also interesting for us in PIM to see how PIM has been used and how we might do something else in other scenarios than this.
Okay. Thanks, Stig.
Thank you.
Okay. Thank you.
Thanks.
So, since I will replace Damien, you are lucky, are more beautiful. I'm kidding. I will step here. And the first document I will talk to about is LISP protocol delegated database 3, LISP DDT. Okay. Since the last time we did one update, so in 1.21, we basically took the previous document and really made the bare basic changes that we need in order to submit the BIS document. Now, this time we did quite some work in order to revise and to update and make it better, I would say. First of all, we restructured a little bit the document. So we moved around a few sections so that, in our opinion, the organization of the document is leaner, more clearer. Okay, and we modified a little bit the terminology so to be more consistent. And we inverted the message format, the content description. So because it was read a little bit awkward, that the document started describing how to use a message and what is its content, and you have no clue where this content is actually. So we inverted that order. And we moved the pseudocode and examples in the appendix. So in 8111, there are interesting examples how really LISP DDT works, and some pseudocode in order to understand what are the operations. But these, I mean, are not key of the contribution. Actually, in a certain way, we can drop them and refer to the original 8111. We can discuss this on the mailing list at some point. As I said at the beginning, we did a lot of text rewriting in order to simplify and clarify all over the document, a little bit everywhere, to be honest. We revised the definition of terms, put in alphabetical order, and revised the definitions for clarifications. Where we could, we refer to existing specifications so that we don't have a double definition of a term, okay? And this was suggested last time, we did define the DDT map referral cache, okay? So that more consistent in the text when we describe things. So if you remember at the beginning, there was an inconsistency about the IID. So the extended EID was a concatenation of several fields. So there is the database ID, okay? Then in the 8111, there is the IID, okay? Which is defined as 32 bits, okay? And then there is the AFI, so the address family and the prefix, okay? But in the specification of LISP that are standard track, the IID is a 24 bits field. There is no 32 bits anymore. So the option where should we redefine the extended EID in this way, as you see in the slide here, or we should define it as a 24 bits, but put a padding there. At the end, we decided not to put the padding because at the end of the day, on the wire, so through all the messages that we see on the wire, the IID is always 24 bits. So even if in all the implementations where you use a 32 bits field in order to store a 24 bits field, there is no issue. I mean, you receive a message, you have 24 bits, you put it in 32 bits. Usually you are putting the most important bits, the byte to the 0. Shouldn't be a problem at all for interoperability. Okay, and this solves one of the concerns that we have. The next one is the database ID, which has a cumbersome definition actually in the document. It says it allows the definition of multiple databases, but it doesn't state if these databases are the same like the one defined here. Okay, when you stop at that sentence, you may say, okay, LISP-DTT can have several instances, let's say, and you identify different instances of the LISP-DTT through the database ID. That's not the case, because then you read implementation compliant with this document must set this field to 0. So this field is 0, always, okay? And is never sent anywhere. Any message, it's like the IID. Any message, there is no database ID. So all the implementations basically by default use 0. So the question is, and we will send it on the mailing list, is whether or not makes sense to keep it, okay? Because basically it's not used. And if you then define a totally different database, okay, which is not a different instance of DDT, is a totally different database. So maybe you need more consistent specification, and you need something more than a database ID. Okay, these are our thoughts as editors. But yeah, we need to check this point on the mailing list. Okay. And we updated a little bit the map referral message format, okay? Because there were few fields that actually are not used. So the original format has been done in order to, in a way that you reuse code. So basically it's the map request, map reply format that we have in LISP. So basically the map referral uses the same thing, but there are fields like priority and weight, or multicast priority and multicast weight, that are not used, are not mentioned anywhere in the document. So it doesn't make sense to keep this format. So this part is reserved, okay? Maybe used in the future, maybe not. Okay, so in this way, we are completely aligned with the RFC 9301, okay? And yeah, we did quite some work on the different figures that we have, so that we can also do this in SVG format. Prasad, do you want to ask the question now, or is it just at the end?
At the end is fine.
At the end? I actually don't. So this slide is actually the same that we had in 121. So we said there is some work to do. So revise the document to make sure residual text about routing scalability is dropped. This has been done. Revise the pseudocode and the example. Done. Still the question whether or not these are necessary, but we can ask this on the mailing list. We revised the extended idea format, so this reduced the IID field to 24 bits. We defined the DTT map referral cache, okay, and we revised the text. So the only outstanding question, even if the box is misplaced, is whether or not this document is ready for a working group adoption. Okay. Any question or comment? Prasad?
Yeah, thanks, Luigi. Yeah, Prasad, Cisco Systems. So I think I'll take an action item to evaluate the multicast fields before you take a call on removing them. I'm not saying that we should not or should remove them, but I'll just study and get back. I'll take an action item on that.
Sorry, Prasad, can you repeat? I didn't get it well, what you mean.
Oh, okay. Sorry.
Pick up a little
sorry.
bit.
If you go a couple of slides back, you were referring to 2 multicast fields. Can you go back to that slide?
You mean here?
Yes. Yeah.
So
yes, the M priority. Yes.
Yeah. So basically, what you have here, where is the record, is a referral. Is not is a locator or of a DDT node that has information about the EID you are looking for. So you don't is not a multicast value. So you don't use the multicast priority and weight. Okay. The document doesn't give sets any priority and weight for the different locators of DDT nodes, because basically they are different. If you have different RLOCs for the DDT node, it is assumed that these are different DDT nodes. So it's a little bit like in DNS. You try one, if you don't have any answer, you try the second, and so on and so forth.
Got it.
And since this is how it's been defined. So obviously you can ask, yeah, but you can use priority and weight in order to do load balancing between different DDT nodes. Right.
Yes.
But this is not something that was defined before. And since we are just moving to standard track, the experimental implementation, and we don't have experience with this type of solution with priority and weight, we prefer to say we don't use it.
Okay. Okay. I'll probably look at it and get back on the list if I have any further comments. Thank you.
You're welcome.
I have a question. Reading the draft, there is something that was, possibly you might want to consider is to detail a bit how you're going to deal when, for example, you have multiple lookups of you go from one database to another, and if that fails, what do you do? I think there are multiple negative cases that would benefit if you have a section for them.
Negative cases, you mean that something goes wrong?
Mm-hmm.
Yeah. It's true that the document goes quite far in order to describe how things works, but doesn't go that far in what happens if, by any reason, doesn't happen.
Yeah. So how do you recover? Right?
Yeah. Good point. Something to work on.
Yeah. Exactly.
Okay. Should we move to the next one, or do you want to run a call?
Do you want to ask for what
Oh, we can do it on the mail list.
we can ask it now?
Hmm?
Do you want to ask it now? It wasn't the option. No.
Yeah.
Yeah. Okay.
So up to you to decide.
Okay. There is I don't see any more. So we have 3. I'm sorry. So I don't see any more votes coming in. So 3 for now. Oh, more. So let me wait. Right. So it's looking a significant yes. It's about, we've got almost half of the people saying yes. So yeah, adopted. I will have to go on the mailing list anyway.
Okay. Not traversal. This is one of the work items we are chartered to do. And actually, this work is also blocking the draft Dino submitted to ICE editor as on the independent stream with an alternative solution for not traversal. Oh, I forgot to update the slide. I'm sorry. So I skipped this one. Just to say that this document has been already presented in March 2012, so it's more than 10 years old. Okay, has been, let's say, delayed a lot during the period that we were working on standard track for the main specification. Okay, then different authors moved to different jobs, so this document has expired a few times. The list of authors that you see there are not really available anymore. So me and Damian are trying to take over the burden and edit this document so that we can publish it as experimental document. There is not that much left to do, to be honest. And indeed, I will go over it, actually explaining the mechanism. So this because has not been presented for a while, okay? And for a large majority of the presentation, I will use slides that have been done by the original authors 13 years ago, okay? So the problem is on NAT-traversal is the fact that you may have an XTR that is behind a NAT, okay? And it's he's still reachable, but the address is private. So we need to create state on the NAT box in order to make it reachable for external traffic. Okay, and there are 2 things to be done. One is discover the NAT. Okay, and then make sure that NAT has states in order that the XTR is reachable on port 4341, which is the default LISP data plane port. Okay. Last. the scenario is where the XTR is actually behind a NAT, but the map server where we query for the mappings is on the public internet, let's say, is not on inside the NAT. Okay, so the basic mechanism is to rely on RTRs, so re-encapsulating tunnel routers, okay, that act as a data plane proxy. Okay, so that basically what it happens is the traffic going out goes through the NAT and the RTR that dispatches to the right destination, and on the other side, anybody willing to reach the original EID sends actually the traffic to the RTR, then re-encapsulate in a way that goes through the NAT to the internal EID. Okay. Now, for the first part, the NAT discoveries, what happens is that this document defines two new messages, which actually has one single format with a bit that makes the disclaimer between a request and a reply. You send these messages to the map server. Basically, what you do is I do an info request in order to using my local airlock, okay, and my own EID in order to tell basically to the map server, you tell me through what is my RLOC and through which RTRs I'm reachable. The info replies come back from the map server and basically says you are reachable through this RLOC, and these are the RTRs that are supposed to do the proxy for you. Okay, and plus inside this message there is the source address used by the XTR and the source address that the map server sees when he receives the info request. So indeed, in this way, we know that if these two addresses are not the same, we are behind the NAT. Okay, very simple in that sense. Now, suppose we discover that we are behind the NAT. What we need to do is to register our private address as an RLOC in the map server. And to do that, we send the map register, but not directly to the map server. We go through the RTR. Okay, why we do that? Because in the RTR, we will keep state about sending back the messages. So what happens is that I send the map register. Let's say, no, in this slide, let's say that the RTR receives the map register, forwards this to the map server, which replies with a map notify to see I registered, and the RTR forwards back to the originator of the map register. We do this using ECM, which is encapsulated control plane messages. Okay, in this way we use 2 bits. So these are all slides that show an R bit. Actually, in the final specification in 9301, there are 2 bits that states that the encapsulated ECM map register has to be forwarded to a map server. And on the way back, this is the M bit. We set the M bit to the register to the map server, and the map notify that comes back from the map server as a E bit that say, send it to the ETR, okay? But what happens is that you send the map register encapsulated with an ECM to the RTR, you create state, especially the RTR registers the public IP address and port number used by the NAT, because the NAT changes port number, okay, and the address, okay. Noting that in this message, the map register, you use as a source port 4341. so that on the way back, the NAT is open, okay? The RTR decapsulate the map register, encapsulate in a different ECM and sends it to the map server, okay? Map server decapsulate from the ECM, does the usual thing with the map register. So basically registering, put it in the database and send the map notify, ask for the main spec, encapsulated with an ECM again, okay, with the E-bit set and send it to the RTR. Okay, the RTR updates the status in his cache. Why this? Because he say now the EID has been registered, so I can start to really act as a proxy. Okay, and then send this map notify back to the source, so the XTR. This time, the previous specification just sent it through a data plane encapsulated map notify. So what it means that you encapsulate the map notify in a LISP packet using as a destination port the one that is registered to traverse the NAT, so that when it comes inside, the destination port is 4341. Okay, so it can go through, basically. And we need the data plane format to do that. Okay. Antoine, you want to ask something now? Sorry, on the previous slide.
So, hello. I have a question regarding the NAT. In the NAT discovery procedure, are you determining the type of NATs you are in front of? And because in the ICE procedure, if in some case, if your NATing is stable with regards to the destination, you could send the register directly to the MS with the public address that the NAT displays for the private one, instead of going through the RTR. So you avoid having to go through the RTR to tunnel on some specific kind of NATs.
Yeah, you can do it only if the NAT is changes only it doesn't change the port number or something. There is a text at the beginning of the document about this, and the most reliable solution is to take into account that you are changing everything, how is explained here, and go through the RTR.
Okay.
This is just state storing. I will not go into the details, but the document also includes the fact that you may have more than one XTR behind the NAT that needs to be registered. So what you use is you use the XTR ID, and there is also a site ID that are already defined in the main specs, and here it is just an application. Okay. So that allows you to say that two different private addresses belongs to the same site, okay? And what happens for the data flow, basically, if someone wants to talk with an XTR or an EID that is behind the NAT, the source XTR does the map request, map reply, okay? Goes to the map request to the map server sends the map reply that actually has as a RLOC, the RLOC of the RTR. The RTR receives the data packet, decapsulate and re-encapsulate with using the states that it has through the NAT and reaches the internal XTR. On the way out is similar in the sense that you send to the RTR, the NAT changes the address and port number. RTR, what it does a map request, okay, to the map server, receives the map reply, has everything that he needs, and he forwards the LISP data to the right XTR toward the destination. Okay, and this is the way basically the mechanism works, and we didn't touch it basically, the main functioning. Okay. What we did is we did some small adjustment. We moved the example to the appendix. Definition of terms revised and put in line with the main specs, basically. There are two main changes that we did. The one is the following. When the map notify reaches the RTR, the original specs say we decapsulate from the ECM and we encapsulate in the LISP data plane and we set the IID, so the instance ID, to FF, in order to identify the inside there is a map notify. Okay, this is too inconvenience. It's a real shortcut. I mean, which implies you cannot use the IID for anything else, and you don't need it because what you need is just you receive the LISP data plane packet, you decapsulate, you re-inject in the protocol stack, and then what happens is, oh, the inside packet is still destined to me, and you redo whatever process you need to do. This is a shortcut that may also lead to security issues, to be honest. So we drop this and we say, you do business as usual, you decapsulate, and then you do whatever you have to do with the internal packet, okay? Which is a map notify, so it has still LISP that will handle it and register the fact that the EID has been registered on the other side, okay? The other change that we did is on the security. So talking about security, what happens is that because info request and info reply have basically the same structure like map register and map notify, the same authentication and integrity can be performed with this one, with these two new messages. So there is not that much to do in that case. However, we have an issue from the other side. What happens is that the ECM, so encapsulated console message in LISP, has its own way to authentify and verify the integrity. Okay, so when you use it, when you use this security feature, you can authenticate the messages between the NAT and the RTR. Okay, or then the XTR goes through the NAT, and the RTR and the map server. So the fact that we receive map register from the NAT, we authentify, we get rid of the encapsulation, we recreate a new ECM and send to the map server. This allows for the RTR to authentify that the message has been sent originally by the XTR. The map server can authentify that the received message comes from the RTR. Now, what is inside is a map register, and we can use the security feature of the map register in order for the map server to authentify that the original map register request comes from the XTR. Okay. On the way back, we can use the ECM authentication feature from the RTR to authentify the map server, okay? But if we use just the data plane LISP packet and then we put directly the map notify inside, there is no way for the XTR to authentify that the message comes from the RTR, okay? The map notify is still can still use the security feature in order for the XTR to authentify the original map server, but there is no way to verify that the message comes from the RTR. So in order to do that, we have to pay a little bit of overhead. So what we need to do is actually take the map notify, add the ECM encapsulation, okay, that allows to authenticate between RTR and XTR, and then use the data plane encapsulation in order to go through the NAT. Okay. There is no such a thing like a free lunch. So if we want to authenticate the RTR, on the XDR, we have to do that. There is no other way around. Okay, so what we did is to specify the fact that in order, if you want to use security, authentify the RTR, you have to use ECM inside the data plane packet. Okay, and this is specified. Sorry, the ECM protection is specified in the LISP sec, okay, in RFC 9303. So it is not, we are not reinventing any security mechanism. We are just reusing what has been already specified. Okay. Yeah, we are actually, the original document said, oh, the type 7 of LISP message is allocated in the main specs, but we verified that it's not the case, so we need to allocate that here, and that's it, basically. Would be good to have feedback, okay, if everything is on track. The ISG rule says that we don't need more than 5 authors on the first page. So we will work out with the original authors on how to deal with this. I mean, me and Damiano, we are just editor, but we need to shrink the list of authors and move some of them to contributors. We did already send an email. For example, Albert Cabello said, I don't have time to work on this. Please put me in the contributors section. Okay. And I think since it's not this huge change in the document, check for clarification, we are ready for a working group adoption. Any question?
I have a question. The changes that you are making, have you thought about the backward compatibility? You said some of them was not a problem, but I'm wondering about the authentication part. And if you remove the FFFF.
Yes, but this was after submission. So basically, if you use this mechanism, is not compatible with existing implementation. So what we need is to add clear text that say, look, if you want to authenticate the RTR, here is what you have to do. However, this is not compatible with early version of this document that use the simple data plane packet. However, since this is experimental, the change can be done. I mean, it's not that we cannot touch because we have deployments, huge deployments, and we are asking for a standard track. So, and also, to be honest, if we don't do it, once we go through security review, they will tell us, do it.
I was going to suggest just to add a section about this, maybe in an appendix or something like that.
Yeah, it's a good idea. It's a good idea. We can also summarize the fact that we switched between 32 and 24 bits from the IID. This has no impact, but still, we did the change. Okay, yeah.
Okay, you want to ask for working group adoption?
If you can have the
You want
working
to ask
group
for...
adoption, yes.
Yeah. Okay, there you go. So no one objects to it. We'll take it to the working list, working group list.
show just the last slide of Alvaro presentation. So I'm sorry we are over time. There was the slides from Alvaro. Just want to show the, let's say, the plan, so that maybe we don't have time to do the call, but here we go. We have a first. You have to close the poll, I think. Here we go. So Alvaro submitted RFC 8060 bis, updated the formatting, XML-v3 and the references. Next step is to change to unapproved experimental types of LCAF. The working group to review merged with 9306, sorry, which is LCAF experimental type or something like that. Anyway, then working group review LISP geo, because geo is proposing a new type of geo coordinates encoding. Review and go for a working group last call. So I was proposing to go for adoption, but since we did not present at all the document, maybe we can do it either on the mailing list or by the next IETF meeting at latest. Okay. And with that, we are done. Sorry for the 6 minutes over time, and see you in Madrid.